Well, 9:15 a.m. on reInvent Friday. These must be the true believers here. All right, well, it says something here about getting started with AWS identity, so let's do that. And as a matter of fact, you know, at least from a security perspective, actually from any sort of a builder perspective, getting started with AWS kind of means getting started with AWS identity. I'll explain. Okay. So if you think about security before the era of the cloud. Now, I'm going to grossly exaggerate the state of the world there, just kind of make a point, right? If you think about, you know, what you had like a data center, some servers in it, some databases in it, right? How do we secure this thing? How do we keep, you know, unwanted access out? Well, you know, network firewall, maybe around the whole thing. Once you're in, you're good, but once you're out, you know, you're behind this, you know, you're outside this firewall. Right? You know, you put, you know, like somebody's in charge of this security, not happy about it, right? And, you know, maybe the security is mostly at the perimeter, and you know, there is maybe a little bit of finer grain control in there, but if you're going to have some finer grain controls in there, it's typically kind of, you know, domain-specific things. You have to be an expert at, you know, database access controls. And that's kind of the world before the cloud. We moved to the world of the cloud in AWS, and the elasticity of the cloud is a direct consequence of the fact that everything is, you know, pay for what you use, provision things with APIs. I mean, that's why you can work so much faster in the cloud than you could before. And, well, everything's controlled by APIs, which means that you have authentication and authorization at every level. Everything in AWS that you access is mediated by AWS's authentication and authorization. That's AWS Identity and Access Management. So, if you're going to build anything at AWS at any level, these are the security controls that you're going to need to use. And the nice thing about it is they are not only pervasive, but they're pretty uniform across the surface. And, you know, of course, this is not the only thing that you use to secure the workloads you build in the cloud. There's a whole bunch of, you know, you may have spent the whole week here at reInvent looking at various security services. This isn't even close to a complete list. We do a whole separate security conference in the summer. You know, it's called Reinforce. We have these security services to assess, you know, to do advanced threat detection and all kinds of ways to assess the posture of your environment and understand what's going on. Moving down a little bit, we have application level security controls, you know, for example, certificate management to give you encryption in transit, key management service to encrypt your data, virtual private cloud, network security controls. And all the way at the bottom of this pig pile, the service that 100% of AWS customers use is identity and access management. That's the fundamental security control here in AWS, and that is what we're going to go into today at length. So this is a talk here for builders. You're in the right place if you're in some kind of engineering or operational or security engineering kind of role. If you're actually building things yourself and putting them in the cloud, this talk is going to give you some very concrete, hands-on practical skills for securing those things. And we're going to do this in a way, this is kind of, as an engineer, the way I like to learn about things is I like to kind of distill them down into first principles. I feel like if I understand the parts of it and how they fit together, I then have a much easier time, you know, applying these patterns and building things out of them. So that's how we're going to do it. This is going to be a real sort of nuts and bolts introduction. We're going to start with talking about authentication. I'm going to go a little bit fast through that part, but just so that you understand how you, as a human being, authenticate to the AWS environment so that you can either recognize the pattern that you're already using or you can choose a pattern that's appropriate for what you're doing. And then we're going to do lots and lots and lots and lots and lots of IAM policy. If you want to see IAM policies, you've come to the right talk. If you don't want to see IAM policies, I don't know. We're going to do a lot of IAM policies. By the time you leave, you're going to be pretty good at writing a least privilege access policy. This is very easy to do from first principles, and that's what we're going to do. and then a few pro tips at the end. Okay, and my hope is, you might be new to AWS. You might have been building on AWS for a while. You might have joined a project that's using AWS and you're trying to understand it. Anywhere you are in the learning curve, I'm kind of hoping you come away from this with an understanding or a perspective of how at least authorization works in AWS that you may not have had before. Okay, but in order to call any of these Amazon Web Services, in order to call any of these APIs, you need to be authenticated. And let's talk about how human beings, people like you and me, authenticate to AWS, how they get in. Well, first thing you got to know is, when you showed up if you've ever showed up to AWS with a credit card, what you end up with on that first day is an AWS account. An AWS account is a container with a small c, for resources, things, and identities in AWS. It's your stuff in AWS. It's got a 12-digit account number. It's a little box of resources. Now, if you show up to AWS with a credit card, you're a hobbyist, you're building stuff, you might only have one AWS account. But in any kind of an enterprise environment, any kind of work environment, whether it's a small one or a large one, you're probably going to have a number of AWS accounts. And they're probably, in the modern era, they're probably going to be collected together in something called an AWS organization. Okay, so why do you have these different accounts? Well, if you imagine you're kind of a small business, maybe a startup, you probably have a production environment and a development environment and a test environment, these different staging environment, these different environments, maybe a small number of them, and you'd want an account for each, right? Because you want to keep those environments very separate. Each should have its own box of things, each should have its own set of identities. So that's kind of the simplest case. Now, if you're a much, much larger organization, you're going to have many of these accounts. You might have hundreds, you might have thousands, different divisions, you might even put a workload each in its own account, and you might use AWS organizations to kind of divvy these up by organizational unit that maybe follow your business divisions. The organization also has something called a master account. You typically don't put anything in that. That account pays the bill and controls a lot of the security controls throughout the organization. We'll talk about those later. But one thing you got to know, since we're here to talk about AWS identity, your identities in AWS, your IAM identities, they are resources, things in AWS too, and they live in these accounts. Okay, so what are the so how do you become one of these identities? Because in order to make any of these API calls, you got to be one of these identities and one of these accounts. So how do you become one of these identities? Well, there are a number of ways out there. The most basic of these is something called an IAM user. You'll also hear me use the word IAM principal. Principal just means caller. It means like somebody in IAM who can be authenticated. So an IAM user is a kind of IAM principal. And an IAM user has some long-term credentials. For example, if you are signing into AWS in a way that looks like this, where you're entering a username and a password, you are signing in as an IAM user. An IAM user is kind of a standalone identity in AWS. If you're using the IAM user identity programmatically, like in our command line interface, you'll have an alternative set of long-term credentials. Will be an access key ID and a secret key. But it's a similar concept. They're long-term credentials. IAM users are great for kind of the getting started mode, the small scale mode, where you don't have your own directory of users, you don't have your own directory of record for users. You got a small number of users, you got a small number of accounts. You're going to be managing these long-term credentials, with good password hygiene and all of that. You'd be an IAM user. Moving up the food chain a little bit, in an environment where you have, multiple accounts, but not a huge number of accounts. You might be using our service, AWS Single Sign-On. Now, Single Sign-On is integrated with organizations. In Single Sign-On, one of the modes in which you can use it is to create your users, directly in single sign-on. It's called a single sign-on user pool. You create your users there. Now, if you kind of look at this picture, you can see what happens is they're actually authenticating to single sign-on, and then they're getting mapped into different roles. That's a different kind of IAM principle. We're going to be, almost everything we talk about today is going to be a role. They're being mapped into different roles in these AWS accounts. Now, the nice thing is that each human being is only going to get one, even if there's many accounts here, each human being is only going to get one set of credentials to manage, and the mappings, the entitlements are done up in single sign-on. So, you know, when you have like simple rules about who should get into what, and a relatively small number of users and not a huge number of accounts, this is a good way to do that, to map people into roles. One thing about roles, we'll talk about this a little bit more later. Roles, unlike the users, do not have any long-term security credentials. When you're in a role, you're in a session for that role that has temporary credentials. As security people, you should, you know, your security ears should recognize that as somewhat preferable. So the roles don't have their own long-term credentials. The long-term credentials come from that user pool. And so in a single sign-on, like if you're using single sign-on, you'll be signing in with your credentials from your user in the pool, and you wind up, it takes you to this page where, you know, you see a choice of the different accounts and roles that you're entitled to. You click through that, and then you end up in one of these role sessions. We actually, on the topic of single sign-on, we announced just last week an integration with Azure AD. So if you have like Office 365 identities in an Azure Active Directory, you can now take those identities and get them synced into single sign-on. So the cool thing about that is if that is your directory of record, your people are signing in with those credentials, so there isn't a new set of credentials to manage. And then, again, in single sign-on, you would map these entitlements, you know, based on users and group memberships into these different roles around your account. So it's definitely something to look at if you have your identity, if your directory of record is an Azure Active Directory. There's more options here. For example, if you have an on-premise Active Directory and you're running Active Directory Federation services, in Active Directory Federation service, there's their claims language. It's a DSL and Active Directory Federation service, again, where you can make, an Active Directory administrator could make these mappings of your users to different roles. You know, that would look like this. This is my Active Directory Federation service. It's not very beautiful. But, you know, I would sign in here. Again, these are my Active Directory credentials, and I'd get shown a choice of the different roles that someone had entitled me to. Going even further up the food chain, some of you might even be using a custom federation provider. If there's some sort of like app or tool that was written by your organization that's mapping you into roles, that's what's going on here. I'm not going to go into a lot of detail of like how to build these or anything. But the point of the previous part is, you know, you might be working in the capacity of somebody who is deciding how people get into AWS. And so I wanted to give you kind of a flavor of your choices here, right? If you have and the point is if you have a directory of record, it's best to use that because then you don't have to manage a separate set of credentials in AWS, but there are a couple of options if you don't have your own directory outside AWS. The other part of this, if you know, probably most of you in this room are getting into AWS the way somebody else at work told you to, and hopefully now you have an understanding of what that means. You're either landing as a user or a role, but in any case, you're landing as an IAM identity in one of your accounts. That's significant, and as we get through this talk, you'll see why that's significant. Of course, not everybody's human. It's okay. Sometimes, well, I mean, any application you write in the cloud is probably going to be accessing some other resources in the cloud. Like, think about nearly any application you might write in the cloud and run on one of our compute environments. I've got EC2 instances and Lambda functions up here, but there's many, many different compute environments on AWS. There's ECS containers, there's Fargate, you can even, you know, things like SageMaker notebooks, things like Glue, ETL jobs, anywhere where you're supplying your own logic. It's almost always the case that there's some access being made to, you know, maybe some data that you have in the cloud, and so that's going to be an API call. It's going to be authenticated and authorized, and in order to do that, you need an identity from which to make those API calls. And that identity would be an IAM role. Our compute environments are integrated very, very nicely with these IAM roles in such a way that when you're doing this, you, as the engineer, as the developer, do not need to handle any credentials at all. You just associate a role with this instance or with this Lambda function, and the temporary and the compute environment takes care of obtaining the temporary credentials and making them available really seamlessly via the AWS SDK to your application. And it's really easy to do, and that's how you give your application code permission to do the things that it does. I'll show you how that looks in the AWS console, because you will definitely see this console page. This is the console page that you see as you go to create an IAM role. And you'll notice over here that there's 4 choices. The first of these 4 choices is, is this going to be an AWS service that's running under this role? It's asking you, is this going to be a non-human process that you need to have access to this role? Gives you EC2 and Lambda as the top choices because those are by far the most common, but you see there's a really long list down here. You'll also see that there's a number of other options here, another AWS account, we'll talk about that later, and then there's the human access options over there. So this is how anybody who makes an AWS call needs to be authenticated. This is how they get their identity. Okay, but once you have an identity, you need permission to do something, right? Being somebody isn't enough. You actually have to be in AWS. Any resource you access, you have to have had specific permission to access that resource. So there's an easy mode here. I'm going to show you this. I'm going to show you the easy mode. I'm going to tell you when it's appropriate to use. And then we're going to get beyond easy mode. You're going to be able to go beyond the easy mode here. But the easy mode here, if you go to the IAM console, you'll definitely see this page. Go down the left rail, policies, and there's a really long list here. And the first thing in the list here is our administrator access. That does exactly what you think. It gives whoever has that policy permission to the whole account. Now there's, the search bar here is, you're definitely going to be using that. Each AWS service has a number of managed policies. These are kind of curated lists of permissions that we have put together that if you're using, I guess the next one on this is Alexa for Business. If you're using Alexa for Business, this is the set of policies that you would need for that. We also have some managed policies that map to, job roles like database administrator, network administrator. These policies are really useful for assigning human access to AWS environments. And the reason why is we humans, we're complex beings, we have hopes, we have dreams, we have ambitions, we take complex set of actions on complex combinations of actions in an AWS environment. So that database administrator is going to need permission not just to the relational database service, RDS, but also to a couple of adjacent services, like a few actions in EC2, and these policies take care of that for you. We've already thought through what the sets of permissions that you're going to need. I'll show you, this is the first policy we'll look at. This is the administrator access policy. It's pretty simple. I'm going to allow you to take action star to resource star. That really does mean that you can do everything. But I'll show you a different one. This is the read-only one, another really useful managed policy that we have. And this one actually has got a pretty long list of permissions. You can see that it's, for each and every service, we've sort of, we've listed out the set of read-only APIs. So this would be a really good set of permissions that you would need if you were going to go into an AWS account and look at things, but didn't, for operational safety reasons or because you don't want to authorize this person to make changes. You don't want to actually have the permission to make changes. So as a result, at a very bare minimum, if you're setting up an AWS environment for human access, you're probably going to do more than this, but at least I would do this. In each and every one of your accounts, you're going to need an administrator role, or an administrator user if you're using users. But you're going to need an administrator role in each of your accounts because somebody's in charge. And you're also going to want a read-only role. And even if it's just a silly test account, you'll want a read-only role. This is just for operational safety reasons. If you're going in there and you're not going to make changes, I prefer to use read-only roles to access my AWS environments unless I actually know I'm going to be making a change. And that way, if I accidentally click the wrong button, I won't be able to make any changes. So you'll want admin and read-only at least. And you'll probably have a few more roles. Like maybe if one of these accounts holds a database, you might have one for a database administrator. You might be writing some of these policies by hand if you want to be like very specific about what a specific human should be able to do. But this is kind of the idea. So easy mode, or these managed policy combinations of permissions, good for the complex sets of things that human beings do. Not so much for your applications. Your applications, the code that you write, does very specific things in your AWS environment. It accesses specific resources and does specific things to it. It's totally deterministic. It's code. You know exactly what it does. So you should write policies for those applications that match exactly what the application does. That's the principle of least privilege, and that is what we're going to get into right now. So we're going to talk about authentication and authorization. Actually, before we get into how to really write a good policy, it's kind of helpful to understand how I'm going to give you a little bit of a peek under the hood of how authentication actually works in AWS. If you don't understand this part, it's okay. And the reason why it's okay is because all of these methods that you could be using to access AWS, whether via our console by pointing and clicking, or with our CLI, or with our SDKs, they're all doing this part for you. So you don't really need to know about it, but in case you're curious, which you probably are, this is how it works. So I have an identity, an IAM role. It's going to make an API call to a service. Let's call it, say, DynamoDB, our NoSQL service. Let's say we're going to call list tables. That's an API that I would call to get a list of the tables in this account. And of course, this call, like everything else in AWS, it's authenticated and authorized. This is a role, so it's going to have some short-term credentials. So let me show you what goes on there. You can, in fact, see what I'm about to show you in the command line interface if you do a -- debug. Show you the headers. OK, so you can see a couple of things here. You can see I'm calling the DynamoDB endpoint in Ohio, US East 2. The interesting part here is the authorization header. You'll notice that there's a credential here. If you've ever used AWS, this credential part that's your access key ID. We pass it in the clear because there's nothing secret about it. I X'd it out here just sort of as a good hygiene practice, but I could have shown you my access key ID because there's nothing secret in it. The secret part is your secret access key. So the access key ID is an identifier in AWS land about the caller of this, the caller of this API call, who they claim to be. Right? They haven't proven that they are this person yet, but this is the principle that they claim to be. Now the signature at the bottom, this is an HMAC signature. It was produced client-side with the secret access key that belonged to this, since it's a role that belonged to this session. And the important parts of this API call were signed, and that means this was definitely made by whoever this ASIA principal was. It was definitely made by them, and the contents of the request haven't been tampered with. So this call makes it over to the service, and like DynamoDB, and DynamoDB makes sure that the signature checks out. That this call is actually being made by this principal who it claims to be in that credential field. OK, so you didn't need to know that part because that whole signature thing, we document how to do it, but you'll probably never do it yourself. You'll probably be doing it through our SDK, command line interface, console. But once you're in, of course, that's not the end of the story. OK, so now we know who you are. Did you actually have permission to make that call? Now, this is the part you do need to understand. So let's imagine you had a role trying to access some resource. In this picture, I guess we'll be accessing some data from an S3 bucket. Here is exactly and literally how it works. So there's a bunch of policies associated with this request, associated with the principal making the call, sometimes associated with the resource, sometimes associated with a number of other things. These policies all get picked up. Now, these policies are full of all kinds of statements, right? There might be a statement in one of these policies that's talking about permissions to EC2. Well, I'm obviously not calling EC2 here, so that statement is not relevant. So we do a bunch of string matching. to figure out which of these policies are relevant. Some of these policy statements will match the statement, most of them won't. We'll take the ones that do, and then each of these statements either has a verdict. It either says allow or deny. And there are some very, very simple rules here. Somebody has to allow it, and nobody has to deny it. And if nobody says anything about it, it's not allowed, right? In AWS, you need literally permission to do everything that you do in order to be able to do it. End of story. So, if you imagine in this hypothetical situation where I'm calling, S3 get object, I've got, I found two statements that apply, and this one says allow and this one says deny. I'm not going to be allowed to make the call. That's how it works. Very, very literal. Oh boy, this is very, very literal. So we're going to break this thing down to first principles. I'm going to show you in great tedious detail how this string matching occurs, how these policies get picked up and evaluated. And we're going to do this with sort of 4 examples. We're going to kind of work through them in detail. And the thing you got to remember throughout all of this is IAM is very literal. We're just coming off last week. If you're, if you live here in the U.S., last week is a great American holiday. It's called Thanksgiving. Many of us get together with our families, and maybe you have a cousin or somebody who like when they come through the door and you ask, "Can I take your coat?" They're like, "I don't know. Can you?" That's kind of, IAM is a little bit pedantic like that. Like that's exactly how it works. Just remember that guy when you're doing IAM policy and you'll be just fine. Okay, so let's get into our first example. In this scenario, I wrote an application. I'm running it on EC2. I've got an IAM role associated with this EC2 that I want to give that IAM role permission to read and write some data from this DynamoDB table that's part of my application. That's what this application does. Got to make sure I have permission to do that. I want to make sure I have permission to do that and nothing that I didn't need. All right, well, let's get started here. Let's write some policy. That's going to work. I definitely have permission to do what I need to do for my application here. So that's all actions. I'm allowed to do all actions with all resources. So this statement's going to match literally anything I do in AWS, and it's going to allow it. I'm going to introduce you here to the least privileged face of judgment. Does not like it. No good. That's a lot of permission that you didn't need. Like permission in services that you're definitely not using from this application. An application never belongs with a policy like that, ever. Okay, let's do a little bit better. It's just DynamoDB. I don't need to make calls to I don't need to make calls to, I don't know, CloudTrail from this application. So, okay, all DynamoDB actions, again, all resources. LPFOJ, not so good. Keep going, could do better. Okay, specific actions, right? Like DynamoDB has a lot of APIs on it, right? DynamoDB, there's APIs there where I could delete a table. There's APIs there where I could change the provisioning of a table. My application uses the table, it reads and writes data, but it doesn't need to do these other things to the table. It's not making, what we'd call control plane changes to DynamoDB. I looked at my code. It calls these APIs. So let me write a nice least privilege policy that's these specific APIs that are about reading and writing items in a DynamoDB table by their primary key. Okay, now I'm still with all the resources. LPFOJ's doing a little bit, he's not mad, he's disappointed. All right, how do we do better than this? Well, one of the keys to writing a good policy is knowing how to read the IAM documentation for that service. Now, I know that sounds kind of funny, but this documentation is structured in a very specific way to help you write, a good literal least privilege policy for your application. This is my favorite page of the AWS documentation, bar none, actions, resources, and condition keys for AWS services. It's a super exciting name, but it's actually very, very useful. If you go follow that link, you'll see a list of each and every AWS service, so you'll go to the page for the service that you're trying to write a good policy for, so I'd go to DynamoDB, and you'll be faced with a nice, big, structured table It tells you how to write the policy. So, you know, I cared about DynamoDB get item, so this is what the row looks like for DynamoDB get item, and you'll notice the action here is get item, and there's a couple of other fields telling me what else I can do here. We're going to get into all of these here. But back to my policy, looking at that table, I see that I can, the resource that applies when I'm going to do a get item is a table. I can write specific, I can authorize specific tables. That's what it's telling me. So let me put that in my resource field here, okay? All right, now you notice I have this long, complicated string to describe my table. That's something known as an ARN, an Amazon resource name. All of our resources have them, and they're all kind of formatted the same way. You'll see there's the name of the service, there's the region, there's your account number, and then there's a service-specific part. Fully qualified name uniquely identifies your resource across all of AWS. So, okay, I have specific actions, and now I have a specific ARN for a table. LPFOJ is now happy about this. Okay, how did I get to that? Well, the way you get to that is you go and you look at, so back to this documentation, it said that for a get table, I could authorize the table resource. I can click on that, and it'll show me, each one of these pages of documentation will show me how to spell the ARN for that resource. So you can see here, now I know how to put this together, and if I bring back that resource ARN that I wrote, you can see that it does follow that pattern. So that's how you do it. I've written a nice least privilege statement. It's going to match the request. Actually, I'm going to show you how this request gets matched, because as we get into kind of more advanced policies, you'll want to keep this in mind. My application here, it's, this is, you know, if it were written in Node.js, it might look like this: DynamoDB.putItem, a bunch of parameters. And, you know, this role that's making the call has a policy associated with it, and this is how the string matching works. Well, the action put item matches the action put item in my statement, and the table name, my table, DynamoDB will construct the ARN out of that, and it will match that to the resource that's in my policy, and that's why this statement gets picked up, and that's why this call gets allowed. That's how it works. So let's do our next example. In our next example, I've decided I'm writing a specific policy, maybe now for my human users. Maybe these are for my developers and kind of like a development sort of science project kind of account. And I've decided that, you know, I really like my developers, but I don't want to spend a lot of money on them. I want to give them access. I want to let them launch the lower cost, some of the lower cost EC2 instance types. I don't want them launching a, you know, P512 2000 extra large, right? I don't want to pay for that. I know they don't need it. I want to be very specific. I want them to launch EC2 instances, try things out, but I want it not to break the bank. So, so what I'm going to do here is I'm going to write this user a nice specific policy. But actually, we're going to do a little bit of an audience challenge here. I'm going to show you 3 options, and you're going to tell me which one achieves my goal. Okay, you ready? Option A. Now, the action for launching an EC2 instance is called run instances, so I have that part right. You notice that I have a star here at the resource. You notice I have a new thing here called a condition. If you noticed that when I showed you that snippet of the documentation table, there was also a condition column. The condition, it takes an operator string equals, and I'm saying that the EC2 instance type has to be T3 nano or T3 micro. That's what this condition means. Okay? All right. So that's option A. Option B is exactly like option A, except that for the resource part, I looked up how to write an ARN for an EC2 instance, and I put it in there with some wildcards. Option C is just like option B, except I've got this other policy statement that talks about a bunch of different resources that aren't the instance. Okay, we're going to do an audience vote here. Who thinks this is the right policy, option A? Who thinks it's option B? Who thinks it's option C? Keep your hand up if you're answering option C because it was the longest one and you figured it's definitely going to be the most complicated one. Yeah. All right. Let me explain why it's option C. You're very good test takers, everybody, and I'm so proud of you. So is the LPFOJ. Well, again, IAM is literal and pedantic. So if you imagine, if you've ever called EC2 run instances, or even actually just walked through the EC2 launch instance wizard, you notice there's quite a few parameters there. You get control over a lot of different things when you're going to launch an EC2 instance. It's not just what instance type, but also things like what subnet you're going to launch it into, which implies an availability zone, implies a set of routing, what security group, who should be able to get into and out of this instance, what AMI, what image ID, like what's going to be running on the instance, all kinds of parameters here. Gives you lots of control. Well, you know what? IAM gives you a lot of control too. If I showed you, I can't really show you the screenshot for the run instances row over here because it would just be too much for a slide, but you should go and look at it. If you go and look at the run instances IAM documentation, you'll see that there's not just one resource being authorized there, but like 7 or 8. Now, why would we do that? We would do that because a lot of these parameters are things you would want to authorize. Like you may want to make rules about which image IDs somebody could launch instances into. You might want to make rules about which security groups, like maybe they're allowed to, launch into the internet-facing security group, maybe they're not. Right? You're going to want to control each of these, and IAM gives you the ability to control each of these. Now, when there are multiple resources associated with the call, each one of them gets authorized, and each one needs to be allowed. And if any of them is not allowed, you're not allowed to make the call. Now, if you think about that from a security standpoint, that is exactly what you want. Right? If you're specifying a security group, you're going to launch an instance into a security group, you need permission to launch an instance into that security group. So here's exactly what happens when we match this API call that you made to policy C. Okay, so going down the line of these different parameters, instance type, well, if I look at my documentation, instance type is an attribute of the instance resource. So that part's going to be authorized against the instance resource. So that's going to match that first statement. So the instance part's going to match this statement. You notice I have a condition here that was allowing T3 micro. T3 micro's on the list. We're going to match. We allow this part. We're not done. There's a bunch of other resources here, and each and every one of them needs to be allowed. So for example, the image ID. Well, it's allowed because of this second statement. This second statement means, all these other parameters, I'm really cool with anything that they do here, but you do still have to allow it. So the image is allowed because it matches over here. The key name is allowed because it matches over here, and so on and so forth down the line. There's about 7 or 8 of these, depending on what parameters you specify for run instances. Each resource gets authorized independently, and each one needs to be allowed. That's how this works. Now, if you think back to those other options, you remember options A and B didn't have that second part. Option A had a resource star. Now, the problem is when it goes to authorize, say, the security group does not have an instance type attribute. That does not make sense. And so that part wouldn't match, and it wouldn't have been authorized. Again, this is literal, and this is pedantic. I don't know, can you, right? In option B, we just had the instance resource, so all of these other resources, when they tried to find a statement that matched them, found nothing, and since nobody said anything about the resource, it's denied, and since all of the resources aren't allowed, the call is denied. So that's how this works. Okay? So let's do some more super literal policy writing here. Scenario 3. Many of our services that hold your data also offer really easy to use encryption integrations with KMS, Key Management Service. It's usually exactly as easy as saying, yes, I would like the data encrypted. Here is the key I would like you to encrypt it with. It's pretty much that easy in most cases. I want to make sure that when people write to this S3 bucket, that they be encrypting that the objects be encrypted with a specific key. I care about how encryption is done. I want it done with a specific key. This data is very important to me, and I want very tight control over it. Okay, let's try to do that. Let's write a deny policy. And the good thing about deny policies is they're pretty simple to, if you see a deny policy, you know it is definitely going to take effect if it matches the statement, regardless of what other policies are out there in the mix. So they can be pretty useful that way, and that's how I want this to work with the S3 bucket. No matter what other policies are in place, I want to absolutely make sure that the unencrypted or incorrectly encrypted objects aren't there. So I'm going to write a statement like this. It says deny S3 put object. That's how you put objects in S3. The resource, the object of a put object, the resource would be an S3 object. That's how you write an ARN, or that's how you wildcard an ARN for object in a bucket. And now there's this condition here. I'll just explain this one little, so I'm denying access. This if exists suffix to this operator. If exists is useful when you have to think about, well, you think about the different sort of encryption dispositions that are possible when somebody puts an object in a bucket. There's actually three possibilities. Well, the first possibility is they encrypted it with the right key. And so that's good. I want to allow that. Don't want my deny policy to match that. The second possibility is that it's encrypted with the wrong key. And the third possibility is not encrypted, right? And I want to deny it unless it's encrypted with the right key. Strictly speaking, this isn't necessary because this field always exists, but this is kind of, I find this much easier to think about with the if exists. I find it much easier to think about when you have a condition. If you think about all three cases, right one, wrong one, and absent, and you use if exists to help you. If exists evaluates to true if the thing isn't there. So if if this field weren't there, I would want it denied, right? The field's got to be there, and it's got to be set to the right value in order for me to allow this. Okay, so now I'm blocking, calling LPFOJ likes how specific we are about this. Okay, got a question for you. So can this guy write the data now? What do you think? Well, Betteridge's law of headlines says no. Why would I be asking you if he could write it if he could write? The reason why he can't write it is because nobody said he could. IAM is literal and pedantic. Nobody said you could write the data, and therefore you cannot write there's only a deny statement here. It says what you can't do, and nobody said what you can do. Well, let's add something here. You can't write it unencrypted or incorrectly encrypted, but you can write it. Okay, so we're doing better here. We've got an allow that's broad, but a deny that's, that's blocking a specific condition that I care about. We done? Can I write this data? Nope, I can't write it. Why can't I write it? Well, when I'm writing this data with the key, there's actually two AWS resources involved. There's actually two AWS resources involved here. There's the object, bucket. I've got permission to that now. But there's also the key, right? A KMS key is an AWS resource, and I don't have access to do things with AWS resources unless somebody said I did. So I cannot write my encrypted data until I do this. Until I also add an allow to, you'll notice that it doesn't say KMS encrypt, it says KMS generate data key. When you're using these integrations, it's generally the generate data key API that gets called by the service. It does something called envelope encryption. You don't really need to know the details, but that's typically the API that the service will be calling on your behalf as you upload the encrypted object. So you needed permission to do both of these, and now you can write your data, but I know that you're not writing data that's not encrypted with the right key. Got one more example for you here. This example is a little bit different. It's going to kind of show off just how flexible and powerful this IAM language is. So in this scenario, I'm running two different workloads in an account. And each workload, let's represent it with a fleet of EC2 instances. Now in AWS, the way I attach metadata to resources, it's called tagging. Most of our services support tagging. EC2 supports tagging. So I'm going to have my EC2 instances tagged to the project that they belong to. I've got a red project and I've got a blue project. Now I've also, my human beings who operate in this account, I've got people assigned to the red project and people assigned to the blue project. So what I'm going to do is I'm going to create different IAM roles, one that's tagged to the blue project and one that's tagged to the red project. IAM roles are resources, like we've talked about many times by now. IAM roles are resources in an AWS account. They're taggable. So I'm going to take this individual who's in here wanting to terminate an EC2 instance. He's tagged to the blue project, and I want him to be able to terminate instances or operate on instances that are tagged to the blue project, but not those tagged to the red project, because that's not the project that he works on. So that's what I want, and this is how I write a policy like this. LPFOJ pretty happy with this. If you look here, okay, so we understand the top part of this, EC2 terminate instances. The resource for that, if you went to look that up, the resource for that is an instance, so that's how that would look. The condition here, you notice there's a little bit of a variable substitution going on over there. The way you refer to a tag in EC2 is with this EC2 resource tag / and then the key of the tag, so project. I'm saying the tag on the EC2 resource, the tag on the EC2 instance, the project tag, needs to match the project tag on the principal caller. Another thing you could refer to this as is attribute-based access control. This is how we do it in AWS. It's a very handy tool for when you have large or rapidly changing sets of things, like EC2 instances, because EC2 instances scale up, scale down, instances are always coming and going. But if you have them tagged, you can refer to them by group. The other nifty thing about this is notice that this policy said nothing about red and said nothing about blue, and yet it's a policy that you could use for any role that's assigned to a project, and it would have the right effect. So here's how to look for tag-based conditions in your policy, in our documentation. This is terminate instances. Terminate instances takes just a single resource, the instance, and you'll notice that there's a bunch of conditions here, one of which is resource tag. So that's what to look for. Sometimes you'll see it look like EC2 resource tag. Sometimes you'll see it look like AWS resource tag. Resource tag is how you do that. There's another one here that I'm not showing in this action. It's called request tag, and this is for any API you call where somebody's tagging something, somebody's supplying a tag. You can also add restrictions about what kinds of tags they can supply, what kinds of values that they can have for those tags, and so on. All right, so that's the policy deep dive we're going to do here. What did we do here? Well, this is a string matching exercise. We're looking for an allow and the absence of a deny. Somebody has to say you're allowed, and they have to say you're allowed for each and every resource you're going to touch. And if you want to see what resources get touched in an API call, you go and look at the documentation for that API. That's how this works. Okay, we talked about doing this within an AWS account, and as we mentioned at the beginning, you're probably working in an environment where there's multiple AWS accounts. And if you're working in an environment where there's multiple AWS accounts, sooner or later you're going to get into a situation that looks like this, where you have, because remember these identities, they live in an account too. So you have an identity, a role in account 111, needs to read some data from a bucket that lives in account 444, different account. For example, maybe this bucket in your organization contains some config that everybody needs to read, that all these applications need to read while they're bootstrapping. That's fairly common. Okay, I know how to do this. Let's write a policy. We're going to allow, let's say in this case, we need to both list the contents of the bucket and read objects, for whatever it is that this does. List bucket takes the bucket as a resource, so that's you just get this straight out of the docs. List bucket takes the bucket as the resource, that's why I have the resource, first resource there as a bucket. Get object takes an object. The ARN for that looks like the second resource. I could have written these out as two different statements, but it's a little more concise to write it this way, and so, okay. So I have permission to do this, right? LPFOJ, not so sure, right? That is a good least privilege policy, but this should not work, right? If this setup worked, then I would be able to sit here in Becky's AWS account and write myself a policy that lets me access something you own. And we're obviously not going to allow something like that. Well, since two accounts are involved, both accounts need to be allowed in the authorization. And that's exactly how this works. For many of our services, including S3, that kind of anticipate cross-account access as being a common use case, they support something called resource-based policies. They'll also, most services have another name for them that's like specific to the service. S3 will call that a bucket policy. And a bucket policy, well, this is an IAM policy. It's not attached to an identity anymore. It's attached to a resource. It's attached to a thing. It's attached to an S3 bucket that says, who can access me? Now you'll notice that there is a new part here. There's this part here that says principal. It's a resource-based policy. You'll notice that there's this part here, principal. It's something new. And the reason why it's there is because, well, when we had policies attached to identities, we knew exactly what principal they were talking about. It's whoever's making this call, that's who we're talking about. With the bucket has to say who is allowed to take this action. So this notation over here, this AWS : account number here, it does not, you might think it means, okay, I'm just going to allow everybody from this account. It doesn't mean that. It means I trust this other account to write policies to allow access to me. So if that account's allowing access, I'm going to allow access. It's like when you tell your kids, if you're, go ask my spouse, and if they say, okay, I do, it's exactly like that, right? This bucket has said the other account is okay, but now the other account needs to have permission. You notice that we do have that here. So each side is saying it's okay, and that's why this action is now allowed. LPFOJ is pretty happy because both sides of this have been pretty specific in what sorts of permissions to allow. Now you'll find as you scale up, maybe you're in a large organization, maybe this bucket needs to be reached by a lot of different accounts in your organization. Now, of course, you could go back and you could write that bucket policy. You just laundry list out a whole bunch of different accounts. Up to a point, that's totally fine. But at scale, in a very large organization, you're probably going to want a more concise way of expressing this. And so that's why we support something called, this condition called principal org ID. It means what you think. So you'll notice the principal here now says star. Now that's something maybe, maybe your ears are burning a little bit looking at that, but it doesn't mean everybody because there's this condition here. It means, yeah, they can access me, but the principal had better, the caller had better be a member of my larger organization. And as of last week, you can even do this on a, if you had a particular organization unit in mind, that would be called principal OU path. You could do that too. This is really useful shorthand when you're working at scale in a large organization that you might come across. Now, you'll also find, and you might be seeing this pattern in your accounts, you also find that sometimes you need to access a resource in another account that doesn't support a resource-based policy. There's a way to do that too. And I'll sort of walk you through this because I think sooner or later you're going to see this pattern occur in your account, and it's good to understand what's going on. And I'll kind of walk through what's going on here. In this scenario, I've got a role in account 111, needs to get some data from a table in account 444. They're not in the same account. The DynamoDB table happens not to support resource-based policy, but I need to get to it. And I know already that no amount of IAM I can write on this role is going to get me into this table. It should not. And since the table doesn't have a resource-based policy, how do I do this? Well, I do know that if I had a role in the same account as the table, I'd be fine, right? I know how to write this policy. This policy is just going to be like a DynamoDB get item kind of a policy. In fact, if I were this role, I could make this call to get item with my table. But I'm not that role. I'm in account 111, so how do I get in there? Well, in order to get in there, we do something called assuming the role. So, in order to get in there, this is a call to our STS service, Security Token Service. If you look at what assume role actually does, when you call assume role on another account, the return value for this is a set of temporary credentials for a session in that role. With those credentials, I can make API calls as that role. I can assume that role. I can become that role. So if you look at what happens here, this role is calling assume role. It's getting credentials back. Now it is that other role, and now that role actually can access the data. Often if you're using our SDKs, you don't actually have to engage with that at quite that level of detail. You look for classes like role credential provider, names like that. That takes care of all of these mechanics under the hood, but it's good to understand what's going on. What's going on is the first role, called assumed role, became the second role, and then the second role made the access to DynamoDB. Now, if I show you how the permissions policy, how the policies are set up, well, how did I get into the DDB access role? Well, roles are resources too. They support resource-based policies as well. In IAM, those are called either role trust policies. You'll also see them called assume role policy documents. And you'll notice that this policy here, it doesn't say anything about what DDB access can do. It says who can assume me. And all IAM roles have a trust policy because, remember, they don't have long-term credentials of their own. There's no way in other than coming from somewhere on the outside, so the role has to trust somebody to assume it. Otherwise, it's a role falling in the forest and nobody is around to assume it, I think. Well, and over here, the initial role has permission not to make any DynamoDB calls because it's not going to. It's going to make this STS assume role, and the resource for that, that's the ARN for another role. So that's how this works. So the role trust policy, or the assume role policy document, that's the resource-based policy in IAM. Okay, so just to wrap up this part about cross-account access, keep it simple. Keep it simple. If a resource-based policy is available, that's going to be your simplest way to do it. Wherever possible, you can be specific about which principal in the other account to allow. I'd actually recommend just trusting the other account. It'll make these policies a lot easier to navigate. It'll just make it a lot easier for you to reason from first principles about what's going on. And where you need to actually step into another account to take actions from within it, assuming these roles is how that's going to work. So if you see roles with trust policies that refer to other accounts, that is what's going on. On just one more thing on this topic of role trust policy. Remember we talked about creating roles to run on our various compute environments, such as EC2? Well, if you look at, the console will kind of take care of this for you. But if you actually go look at the assume role policy document that got created there, you'll notice that it's like all these other ones, except the principal now says service. It's not another AWS account. It's an AWS service, and that's the name of the EC2 service. So if you see those on your roles, it means the intention is for some AWS service to assume the role and obtain its credentials. Literally what's happening here, when you launch an EC2 instance and associate an IAM role with it, the EC2 service, the AWS service EC2 is calling assume role to get some temporary credentials and delivers those to the EC2 instance where the SDK makes that available to you. That's literally what's happening here. So that's why you're trusting EC2. And another thing about resource-based policies, brand new launch as of last week, we have this thing called Access Analyzer. It's in the IAM Console, a little bit further down the left rail. So resource-based policies are the way that you allow other accounts outside the account is a pretty tight box, and resource-based policies are the way you allow other accounts into that box. And Access Analyzer will go through a number of different resource types, S3 buckets, IAM roles, SQS queues, KMS keys, I think one or two others. And it will go, those that support resource-based policies, it will go and analyze those policies. This is a static analysis using our automated reasoning, so this is using math to do a static analysis of your roles to show you which of these resources is allowing access from the outside. This is a really useful tool from a number of different dimensions. I definitely recommend when you go home, if you have an AWS account, go look at your Access Analyzer report. Some of the things it's finding are intentional, right? Remember that bucket that I intended for other accounts to access? Like that would show up here, and I would archive that finding. I would say that's okay. But you may also discover permissions that you have that you may wish to clean up, or maybe it's a resource you just don't even use anymore because we're now showing you with the IAM role when you've last used it. So maybe there's an opportunity to clean some things up. So your findings are going to look something like that. My bucket, I've made it available to 111. etc. All right, we're going to finish up with one pro move here, and that's with AWS organizations. Organizations offer something called service control policies. So these are IAM policies. They're not on a principal. They're not on a resource. They're on the organization, and they help you make these security invariants, these assertions across your environment like this. We get 22 regions, 4 on the way, more all the time. My guess is either almost nobody or literally nobody in this room uses all of the regions. Right? You probably use 1, maybe 2, maybe a couple. So wouldn't it be nice if nobody in your organization, no matter what kind of privileges they gave themselves, were able to use the regions that you didn't? You don't want to pay for those things, if nothing else, right? Well, that is one example of many useful things that you can do with AWS organizations. It's a deny policy. I mean, it's not granting permission to anybody to do anything. It's taking away permission. And this deny policy is going to get pulled into every policy evaluation for any principal in my organization. And now that you know how to read these things, it's going to say that if the region is not US East 1 or US West 2, I'm just going to deny it. Even if the caller is some sort of admin that gave themselves star, 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 this policy still gets pulled in and this deny still applies. In our documentation page for organizations, we have a number, I think like 12 or so service control policies that map to a number of use cases. If you're running an AWS organization, if you're kind of in an administrative role there, you should definitely go look at those examples, see if they apply to you, because it's a really powerful, authoritative tool where you can just set these invariants across your environment. Okay, so we're at the end here. We're done getting started with AWS identity. What do we do here? We talked about getting in and getting around. Hopefully you can now recognize the way that you as a human are authenticating to AWS and have a deeper understanding of exactly what at a fundamental level is happening as you're accessing these resources. I'm hoping you also understand at a fundamental level how those authorizations work. They're literal, they're pedantic, they're tedious, and you can totally break them down to first principles and get your least privilege policies right. Talked about how to do that. And then finally, we talked at great length about how you go and construct that, perfect IAM policy for the application that you're writing. Now, you're not done. There's homework. This is a technical skill, and as with all technical skills, it requires hands-on practice. And so what you should do is take applications you've built that maybe you didn't know what you were doing with the policy. Try to tighten up that policy now that you understand exactly what's going on here. See how good you can get that policy. A little bit of practice, you're going to be an IAM pro in no time. Thank you so much for coming. Have a safe trip home. I really appreciate your coming out here to reInvent. Thank you so much.